Hello everyone, welcome back to my YouTube channel. This is Monisha.Chandrashekhar, currently pursuing my engineering in Sri Venkateswara College of Engineering, Bangalore in cybersecurity. First year, Galfin section. The topic is sensors in the subject chemistry, so let us begin the session. First, let us have a basic idea about energy systems. A device enables the energy liberated in a chemical reaction to be converted directly into electricity. A battery is a portable energy source with three basic components: an anode, cathode, and an electrolyte. A battery is a device that consists of two or more galvanic cells connected in series or parallel or both, which converts chemical energy into electrical energy through redox reactions. Let us go through some of the examples: lead acid battery, nickel cadmium battery, etc. The size of the present day batteries range from a fraction of a cubic centimeter to several cubic decimeters. Basic components of a battery. A battery is made up of an anode and cathode, which are surrounded by their electrolytes. The anode and cathode are separated by a separator. The outer surface of the battery is covered by plastic layer, and in modern batteries, the ventilator are also provided to escape the accumulated gases during the process. Some more components of battery are anode and cathode. So, anode in a battery, anode is a negative electrode. It releases electrons into the external circuit by undergoing oxidation reaction. In rechargeable battery, it acts as positive terminal, that is cathode, during charging. It gives the electrons to the external circuit. Next comes cathode. In a battery, cathode is a positive electrode. It accepts the electrons from the external circuit. Thereby, reduction of the active species occurs. In rechargeable batteries, it acts as negative terminal, that is anode, during charging. Classification of batteries. Batteries are classified as primary batteries, secondary batteries, and reserve batteries. Primary batteries are also called as non-rechargeable batteries, and secondary batteries are also called as rechargeable batteries. So let us have a brief idea about what it says. What's the meaning of it? So primary battery. The primary batteries which produce electrical energy at the expense of free energy of active materials, and produce energy only as long as active materials are present. Secondary batteries, the batteries which produce electrical energy at the expense of free energy of active materials. These active materials are capable to restore at respective electrodes on recharge and repair for discharge once again. These are rechargeable batteries and can be used again and again. Basically, primary batteries cannot be used again. Once used, you have to throw it. Secondary batteries, you can use it again and again. You can recharge it and use it again. So next comes reserve battery. These are batteries which may be stored in inactive state and are made activated just before they are needed. The activation involving by adding electrolyte, because one component of the electrolyte isolated and stored separately when the battery is required. Here comes the important topic, that is sensors. Introduction. The word sensor derives from the Latin word sensus and means feeler. Sensor is a device that detects and responds to some type of input from the physical environment. Example: pressure sensors, accelerometer, photodetector, pyrometer, etc. It is a type of transducer. What is the meaning of transducer? Let us see here. It is a device that converts energy from one form to another form. Sensor. What is sensor? Converts an physical input into a electrical signal. Example: potentiometer, conductometer, colorimeter. Actuator. Actuator. Okay. Converts an electrical signal to physical output. Example: alarm, LED, electric motor, etc. There are some of the types of sensors which we'll be going through, that is based on conversion, that is thermoelectric, photoelectric, electromagnetic. And based on output, it is divided into temperature and light source. Based on detection, it is divided into chemical, biological, and electric. Chemical sensor. It is a device that is capable to give real-time analytical information about test sample. Example, electrochemical, conductometric, optical sensors, etc. It interacts with a specific chemical analyte, detects it, and produces the signal proportional to its quantity. In chemical sensors, analyte, that is test solution, is a target species which is being detected and measured using a sensor. It consists of these major components that are receptor, transducer, and electrical signal and display. Principle of chemical sensors. Electrochemical sensors measures the concentration of analyte solution by oxidizing or reducing the analyte solution at an electrode. The transducer component of electrochemical sensor consists of working or sensing counter and reference electrode and electrolyte solution. The sensing electrode is chemically modified, therefore it ensures the sensing of oxidation and reduction of the analyte solution. It basically tells whether the oxidation is taken place or the reduction is taken place. The electrolyte is a part of electric circuit of an electrochemical sensor system. Electrolyte is transport charge within the sensors, stabilize the reactants and products for efficient transport and stable under all the conditions of sensor operation. Some of the applications are used for detection of dissolved oxygen in water boiler, oxygen sensor, used for water analysis and environmental monitoring like detection of nitrogen, sulfur, and carbon monoxide and pH of water. Used in diagnostic and healthcare applications like monitoring of glucose, bold Ca2+, Fe2+, etc. Used in soil parameter analysis and agriculture application. Used in security and defense application. Next comes disposable sensors. These are the sensors designed for a single use and then disposed after its use. Once you use it, you need to throw it. Again, it can be used. Example, blood glucose test strips sensors, pregnancy test strips sensors, drug and alcohol test strips sensors, pulse oximeter, insulin pump sensors, etc. Advantages are these are biodegradable and sustainable in nature, which won't harm the nature. These are cheaper than classical sensors so that everyone can afford it. These are convenient to use. So even people who do not have knowledge can use it, means it might be such an easy device like that. These are small and lightweight. You can carry it anywhere. These are portable in nature. What I said, you can carry it, and decreases the environmental pollution, doesn't harm the environment, prevents the contamination of sample, requires short duration for analysis, time is not consumed too much, reduced waste, so that it won't make a lot of waste in the nature. It has a very good advantage. So this brings me to the end of this session. I hope you all have understand what I've taught you today. Thank you very much for listening till here, and I would request you to like, share and subscribe to my channel. This would help me a lot. Thank you.